Factoring perfect square trinomials. All right, so check this out here. We're going to be factoring a special type of trinomial, and it has this very curious pattern here. So check this out. So if you can, if you have a trinomial, which means that you have three terms, 1, 2, 3, 1, 2, 3. So both of these guys are trinomials. If you can write the first term and square it, and if you can write the last term and square it, and then if you can write the middle term as the product of the first term and the second term and 2, so multiply 2 times the first term times the last term, then the factored form of that is just x plus y squared. Okay, and you can quickly figure that. I'm not just making that up by just doing x plus y times x plus y. So if you take x plus y squared, that means x plus y times x plus y. And if you distribute this, x times x is x squared, x times y is xy, y times x is xy, and then y times y is y squared. So we get x squared plus 2xy plus y squared. So see how we get the same thing right here. So this pattern does work. And if you can recognize it quickly, then you can get these pretty quick here. I'm going to go a little slow here so I can show you. But once you see the pattern, you'll be able to factor these, maybe like in a matter of 10, 15 seconds. So can I write the first term as something squared? That's the question. Can I write the middle term as 2 times the first term times the second term, and can I write the last term as something squared? So I kind of like to do this little parenthesis thing. So can I write the first term like my x squared? Well, yeah, right. I can write that as 7z. If I square 7z, I get 49z squared. And now I go to my last term. Can I write my last term as something squared? Well, yeah, I can write 1 as 1 squared. So now, is my middle term the product of 2 times my first term, 7z, times the last term, 1? And since that's minus this right here, should be minus as well. So yeah, I mean, look, negative 2 7z times 1 is negative 14z. This right here is a 49z squared, and that is our 1. So it does fit this pattern right here. I was able to, actually, I think we did the one with the minus here. I was able to write the first term as a squared, the last term as a squared, and the middle term is negative 2 times the first times the last. So the factored form of this is just going to be simply x minus y squared. So my first term minus my last term squared. All right, so this is equivalent to that. This is the factored form, and this is the expanded form. All right, let's do the same thing over here. Let's see. Can I write my first term as something squared? And the middle one is 2 times the product of the first and the last, and the last term as something squared. Well, let's see, 9a squared, well, that's 3a. My last term, 64b squared. Well, yeah, that's going to be 8b. Now, what about the middle? 2 times what? Times what? Well, like I have 3a and 8b. Does that give me 48ab? 2 times 3 is 6, times 8 is 48ab. Yeah, so it all checks off. The first and the middle and the last all check off. So the answer is just the first term plus the last term squared. And there we go.